Hey everyone, and welcome back to this ICSE session of mathematics on previous year questions. So in this particular session we are going to discuss probability all the way from 2018 to 2024, and we are going to tackle questions as well. So here in probability, firstly let us try to understand how many questions were asked from 2018 to 2024 from this particular chapter. So if you see from 2018 to 2024, 2 questions of 1 mark were asked, and a 4 mark question is very important from this particular chapter, because if you see, every year one question of 4 marks is definitely asked from this particular session, right? So now let's try to tackle some problems, and also if you have a look at this, see, 4 marker is such an important question from this particular chapter. You can expect a 4 marker. So let's begin with the first question now. So the first question is from ICSE 2018. Let's try to understand this question. It says cards bearing numbers 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20 are kept in the bag. A card is drawn at random from the bag. Find the probability of getting a card which is a prime number, a number divisible by 4, a number that is multiple of 6, an odd number. So basically there are 4 questions here, correct? So cards bearing numbers from, these numbers are given 2, 4, 6, 8, 10. Basically if you see, all the even numbers are given, isn't it? Even numbers 2, 4, 6, 8, 10, 12 up to 20. Now firstly, if I consider the sample space, can I say the sample space is going to be 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20. And also I need to count the sample points. So here can we say n of s? N of s. Can you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So n of s is going to be 10, correct? Basically 10 even numbers. Now let's focus on the first part. The first part says the probability of getting a prime number. So the first one is the probability of getting a prime number. So let A be an event, let A be an event of getting prime number, right? So A is an event of getting prime number. So tell me one thing, from all these numbers, which are the prime numbers? Can I say 2 is the only prime number? So if I take the event A, so in event A I'll have only 2, right? So can I say n of A is going to be 1, correct? N of A is 1. So if n of A is 1, what will be probability of A? Can I say probability of A is going to be n of A divided by n of s. N of A is how much? 1. N of s is how much? 20. 10, not 20. Where did I get n of s? From the previous slide. So can I say the first part is done? Yes, the probability of getting a prime number is 1 by 10. Now a number divisible by 4. Okay, let's focus here. Number divisible by 4. So firstly, can I say 4 is divisible by 4? Yes. 8 is divisible by 4? Yes. 12 is divisible by 4. 16 is divisible by 4. And 20 is divisible by 4. Correct? Okay. So if I take that as event B, let B be an event of getting a number divisible by 4. Just in a shortcut way I have written it, number divisible by 4. So in event B, what all elements are going to come? 4, 8, 12, 16, 20. Correct? So can I say n of B is 1, 2, 3, 4, 5. N of B is 5. So what will be probability of B? The probability of event B is going to be 5 by 10, right? Which is half. Because if you see, how many elements are there? The elements are 10. Total number of elements I am talking about. And how many numbers are divisible by 4? 1, 2, 3, 4, 5. So 5 by 20, which is 1 by 5 by 10, which is 1 by 2. Perfect. Now third is a number that is multiple of 6. Third part is multiple of 6. So let C be an event to get multiple of 6. We want multiple of 6, correct? Okay. So if we want multiple of 6, can I say it is going to be 6, 12, 18, 3 numbers. 6, 12 and 18. Multiple of 6 is basically a table of 6, isn't it? So C is an event in which I get 6, 12, 18. So can I say n of C is 3. So probability of event C is, I'm writing it directly, 3 by 10, correct? See, these are such simple questions asked for 1 mark each and the total marks are 4. So even if it looks like it's a 4 marker, it's actually a 1 marker because every question individually is so simple. And then we have the fourth part. An odd number. So check how many odd numbers are there. See, already all the cards over there bearing the numbers are even numbers, right? So if I say D is an event of getting odd number, D is an event of getting odd number, can I say in event D, I'll have nothing, right? So can I say the probability of event D is equal to 0 by 10 and 0 by 10 is nothing but 0, correct? So the probability is 0. So I hope you have understood all the 4 questions here of probability first part, that is the first question. Let's continue further. Okay, so let's have a look at a new question now. This is a 3 marker. So it says there are 25 discs numbered 1 to 25. Okay, there are different discs, they are numbered from 1 to 25. That's fine. They are put in a closed box and shaken thoroughly. So they are shuffling it. A disc is drawn at random from the box. Find the probability that the number on the disc is an odd number, divisible by 3, 2 and 3 both, divisible by 2 and 3 both, and a number less than 16. Okay, so firstly, see, let us try to analyze the sample space. So if I talk about the sample space, the numbers are starting from 1. So we have 1, 2, 3, all the way up to 25, correct? So can I say number of elements in the sample space are 25? I hope this part is clear to all of you. So number of elements are 25. Now let A be an event. Let A be an event of getting odd number. Let B be an event of getting a number divisible by 2 and 3 both, and then let us have a number less than 16 as event C. So there are 3 different events, right? We have event A, we have event B, we have event C. So what is event A? What is event A? A is an event of getting an odd number, right? Getting an odd number. So if you see, A is an event of getting an odd number, can I say in event A, what all numbers will be there? 1, 3, 5, 7, like that, right? So can I say I'll have 1, 3, 5, 7, 9, 11, 13, then I have 15, 17, 19, 21, 23, 25, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, isn't it? So can I say in event A, that is n of A is equal to 13. So what will be probability of event A? Probability of event A is number of elements in event A divided by number of elements in the sample space, and that is going to be 13 by 25. That is your final answer. That is 13 by 25. Clear and simple, easy, correct? That was our event A. Let's talk about event B. So event B is what? B is an event of number divisible, right? Number divisible by 2 and 3. See, the number should be divisible by 2 also, the number should be divisible by 3 also. So can I say, if it has to be divisible by 2 and 3, ideally it should be divisible by 6. Obviously, 2 and 3 both. So 6 is the first number. Then can I say 12 is divisible by 2 and 3 both. Then 18 and then 24. So these are the 4 numbers divisible by 2 and 3 both. Correct? So can I say, in my event B, I'll have 6, 12, 18, 24. So how many elements are there in event B? So number of elements in event B are 4. So can I say, probability of event B will be n of B by n of S. That is equal to 4 by 25. Correct? So 4 by 25 is the final answer. That is your event B. And if I talk about event C is a number less than 16. So if I talk about event C is number less than 16. So in event C, I'll have 1, 2, 3, 4, up to 15, right? Basically, number of elements in event C are 15. So what will be probability of event C? The probability of event C will be n of C divided by n of S, and that is equal to 15 by 25. Further divide this by 5, I get 3 here, I get 5 here, and that is equal to 3 by 5. So yes, 3 by 5 is the final answer. Easy, simple, very straightforward question. Nothing much in this. Event A, event B, event C. Event A is odd numbers. How many odd numbers were there? 13 odd numbers, so 13 by 25. Then event B is number divisible by 2 and 3. This and is very important, understand. This and means it should be divisible by 2 also and 3 also. Sometimes what they do is, they'll trick you around and they'll say 2 or 3. 2 or 3. Then you take all the combinations of 2 or 3. That is, you'll take 2 also, you'll take 3 also. You'll take 4 also, because it is divisible by 2. You'll take 6 also, divisible by 2 and 3 both. You'll take 8 also, you'll take 9 also, because 8 is divisible by 2, 9 is divisible by 3. So or means what? You take all the combinations of 2 also and 3 also. But when they say and, basically it has to be divisible by both 2 and 3. Correct? Okay. Alright, so let's have a look at a new question now. It says, each of the letters of the word authorizes is written on identical circular discs and put in a bag. So basically what they are doing is, I'll just give you a visualization here. So there are few discs. In one disc they have written A, in other disc they have written U, something like that. And then they have placed it inside a bag. Now they are well shuffled. So it's not in order basically. So if a disc is drawn at random from the bag, what is the probability that the letter is a vowel? So vowels we already know. What are vowels? A, E, I, O, U. Then one of the first letters of English alphabet which appears in the given word. Okay, this is interesting. One of the first 9 letters of English alphabet, and one of the last 9 letters of English alphabet basically. One of the first 9 letters, one of the last 9 letters of English alphabet which appears on the given word. So let's focus on the first part only, one thing at a time. Here they are talking about vowels. So each of the letters are here. So if I talk about the sample space, let's talk about the sample space here. So in sample space, can I say I'll have A, U, T, H, O, R, I, Z, E and S, because these are the only letters in the word authorizes. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So can I say my number of elements in the sample space are 10. Correct? So n of s is 10. Now let's talk about vowels. So if I talk about the first part, so let A be an event of getting a vowel, right? Getting a vowel. So if A is an event of getting a vowel, let's try to understand this. What all vowels are there? A, E, I, O, U. But here are all the vowels utilized. We have A, we have U, we have O, I, E. Okay, all of them are there. A, U, O, I, E. So I'll get A, E, O, I, U. Anyways, the order doesn't matter. So can I say number of elements in the event A are 1, 2, 3, 4, 5. Correct? So what will be probability of event A? The probability of event A will be equal to n of A divided by n of S, that is equal to, this is 5 divided by n of S is how much? N of S is 10. And 5 by 10 is nothing but 1 by 2. Correct? Okay. Now let's talk about the second part. So in the second part, what are they asking? They are asking about one of the first 9 letters of English alphabet. So let B be that event of getting one of the first 9 letters of English alphabet. I'm not writing down completely. Let's understand that our event is event B. Now what are the first 9 letters of the English alphabet? So if I just put it down here, it's A, B, C, D, E, F, G, H, I, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are 9. Now understand. Out of these 9, if you see over here, how many do you find? Do you find A? A is there. B is not there. C is not there. D is not there. Right? E is there. So A is there. A is there. E is there. Correct? What else? F, G, H. H and I are there, right? H is there. I is there. A, H, I, E. Is there anything else? I don't think so. So A is there in authorizes. E is there. H is there. And I is there. A, E, H and I. So can I say in event B, out of the first 9 letters of the English alphabet, here what am I going to have? Here I am going to have A, B, E, H, I. So can I say number of elements in event B are 4? And if the number of elements in event B are 4, what will be the probability of event B? The probability of event B will be equal to n of B divided by n of S, and that is equal to 4 by 10. And 4 by 10 is nothing but 2 by 5. I hope this is clear to all of you. Simple and straightforward, isn't it? Now, if I talk about the English alphabet, it starts from A, B, C, D, right? So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. You might wonder why have I written that? Because our next question talks about the last 9 letters, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So these are the last 9 letters, and our word is authorizes. So from authorizes, what all letters from the last 9 letters appear over here? Can I say we have S, yes, then R, T, R is there, okay, we have R, yes, we have Z, okay, yes, then do we have, no, H is not there, O is not there, T, okay, we have T, and we have U as well if you see. So can I say if C is the event of getting one of the letters of the last 9 letters of English alphabet, in that the event C will have U, T, R, Z, S. So 1, 2, 3, 4, 5. So can I say n of C is equal to 5. So probability of C is going to be 5 by, how many words are there? 10, right? And that is equal to 1 by 2. I hope this is clear to all of you. Correct? Perfect. Let's continue. Let's have a look at a new question now. It is an MCQ based question. It was asked in ICSE 2023 for 1 mark. So a letter is chosen at random from all the letters of the English alphabet. The probability that the letter chosen is vowel is what? Now this is a simple question, right? Because we know number of vowels. Number of vowels are 5. Total letters 26. So what will be the probability of getting a vowel? The probability of getting a vowel is going to be 5 by 26. If they ask you what is the probability of getting a consonant, the opposite of vowel is consonant. So that is going to be, if this is 5, that will be 21. So 21 by 26. Anyways, consonant was not asked in the question. The question was what is the probability of choosing a vowel, that is 5 by 26. Correct? Simple. Okay. Now let's have a look at a new question. Again an easy question. It says a bag contains 25 cards. So 25 cards are there in a bag. They are numbered from 1 to 25. A card is drawn at random. What is the probability that the card number on the card drawn is a multiple of 5, a perfect square, a prime number? Okay. Let's try to analyze this. It says a bag contains 25 cards. So the sample space will contain all the numbers from 1 to 25. So 1, 2, 3, up to 25. So can I say the number of elements in the sample space are going to be 25, correct? Number of elements are 25. Now we are talking about some events. So let us call the first event as event A. So let us say that we have an event of getting a multiple of 5, that is event A. And this is the event of getting a perfect square as event B. And then we have an event to get a prime number, right? Okay. Now multiples of 5. So if A is an event of getting a multiple of 5, can I say in event A, I'll have 5, 10, 15, 20, 25. When I say multiples of 5, I'm talking about the table of 5, right? So these are all the numbers that lie in the multiple of 5. So can I say n of A? Can I say n of A is 5? And if n of A is 5, can I say the probability of event A is n of A by n of S, and that is equal to 5 by 25. Here you have 5, here you have 25, so that's 5 by 25, and 5 by 25 is 1 by 5. So 1 by 5 is the final answer, correct? So first question is done. Multiples of 5, the probability is 1 by 5. Let's talk about a perfect square. So let B be an event. It's an event of getting perfect square, right? Getting perfect square. Now this is interesting. When I say perfect square, that means that should be square of a natural number or integer. That's okay. So can I say 1 itself is a perfect square because 1 is a square of 1. Square of 1 is 1. So 1 is a perfect square. Then if I talk about 2 square, 2 square is 4. So 4 is a perfect square, but 2 and 3 are not perfect squares. Then if I talk about 3 square, 3 square is 9. So 9 is a perfect square. Then if I talk about 4 square, that is 16. 16 is a perfect square. And then if I talk about 5 square, that is 25. So these numbers over here, they are called perfect squares. Correct? Okay. So if B is an event of getting perfect square, can I say in event B, I have 1, 4, 9, 16, 25. So can I say number of elements in event B are what? Number of elements in event B, 1, 2, 3, 4, 5. Can I say it is 5? Yes. So what will be the probability of event B? The probability of event B will be n of B divided by n of S, that is equal to 5 by 25. And how much is 5 by 25? 1 by 5, right? So to get a perfect square, the probability is going to be 1 by 5. Correct? Easy. So second is done. Then let's talk about prime numbers. So C is an event of getting a prime number. So from 1 to 25, how many prime numbers are there? So if my event C is an event of getting prime numbers, I'll have 2, 3, 5, 7, 11, 13, 17, 19, 23. Correct? Let's check again. 2, 3, 5, 7, 11, 13, 17, 19 and 23. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So can I say n of C is equal to 9? So can I say probability of event C is equal to n of C divided by n of S, and that is equal to 9 by 25. So 9 by 25 is the final answer. That is the probability of the event of getting what type of number? Prime number, right? Because C was an event of getting a prime number. So we have solved all the 3 questions, isn't it? We got this as a perfect square 1 by 5. We also solved it for multiple of 5, 1 by 5 again. And then finally we solved it for this part, that is prime numbers, that is 9 by 25. So there are basically 9 prime numbers. Here they did not say odd prime numbers or even prime numbers. So we'll take all the prime numbers. Sometimes what they do is they'll say only odd prime numbers. They can trick you. In that case, don't take 2. Sometimes they can say only even prime numbers. That means don't take odd numbers, take only 2. That will be 1 by 25. Correct? Okay. Let's have a look at a new question now. This is an MCQ based question for 1 mark. So assertion and reasoning question basically. So dice is thrown once, only once, and the probability of getting an even number is 2 by 3. And okay, there are 4 options. So 4 options are A is true, R is false, first option. Second option is A is false, R is true. Third option is both A and R are true. Fourth is both are false. Basically, you just have to check which of the statements here are true and which are false. Okay, so if I talk about a die is thrown, right? So if a die is thrown, so what will be the sample space? Sample space is going to be 1, 2, 3, 4, 5, 6, right? So when we throw a die, the sample space is 1, 2, 3, 4, 5, 6. Now let's talk about assertion A. So let A be an event that a die is thrown and the probability of getting an even number. So let A be an event of getting even number. A is an event of getting even number, right? Even number. So can I say in event A, I'll have 2, 4, 6. 2 is an even number, 4 is an even number, 6 is an even number. So can I say n of A is 3. So can I say probability of A is 3 by 6 and 3 by 6 is 1 by 2. Okay, what did they say? They said that the probability of getting an even number is 2 by 3. So definitely, I said this is false because it is not 2 by 3. It is 1 by 2, half. Even numbers half, odd numbers half. Now, the sample space for even numbers on a dice is 2, 4, 6. The sample space for even numbers. Sample space. Okay. So sample space they are saying, even if R is some set of getting even numbers, sample space for even numbers. So if I have only even numbers, then what all numbers will come in the sample space for even numbers? 2, 4, 6. Let us check. 2, 4, 6, yes. That means this is true. See, if this is sample space for throwing a die, that is 1, 2, 3, 4, 5, 6. But they are already saying sample space for even numbers on a die. That is 2, 4, 6 only. Correct? So what can we say? We can say that the assertion is false and the reason is true. This is the right option. Easy. You just had to identify. Basically, this is as good as your true or false. Okay. Let's have a look at a new question now. It says, the following letters A, D, M, N, O, S, U, Y of the English alphabet are written on separate cards and put in a box. The cards are well shuffled and one card is drawn at random. What is the probability that the card drawn is the letter of the word Monday? Okay. Any letter of the word Monday. Basically. Simple question. But as of now, let us talk about the sample space here. So what will be the sample space? The following letters are given. So let me write down the letters. That is A. Then I have D. I have M. I have N. O. S. U. Y. So can I say N of S is equal to 1, 2, 3, 4, 5, 6, 7, 8. N of S is 8. That is, number of elements in the sample space are 8. Now let A be an event. Let A be an event of getting a letter. Right? A be an event of getting letter from Monday. So tell me one thing, in Monday how many letters are there? I have M, O, N, D, A, Y, right? Can I say N of A is 6? And can I say M, O, N, D, A, Y? M, O, N, D, A, Y. All of them are here. So 6 out of 8, right? So can I say the probability of event A will be equal to N of A divided by N of S. So probability of event A will be equal to 6 by 8. And 6 by 8 is nothing but 3 by 4. Because if you divide by 2, you will get 3 by 4. Easy, isn't it? Let's talk about the second event, which does not appear in Monday. Okay, so complement of this. So let event B, or you can say A complement also, right? Let event B. So B is an event of getting letter not from Monday. Not from Monday. Right? So can I say in event B, you will have, say if I take Monday, M-O-N, D-A-Y. What is remaining? Only this part is remaining. So can I write down S, comma U? Yes. So can I say n of b is equal to 2? So can I say the probability of b is equal to 2 by 8, and 2 by 8 is nothing but 1 by 4. So 1 by 4 is the final answer, isn't it? And let's talk about which appears in both Sunday and Monday. So the third one, right? That is, we have an event C. So it is in both Sunday and Monday, right? So in event C, can I say I'll have S, U, N, D, A, Y. See, N, D, A, Y I have already taken. So M and O. M also, O also. And this is nothing but all the 8 letters. And N of S, if you remember, had all the 8 letters same. So can I say the probability of event C over here is going to be N of C divided by N of S, and that is going to be a sure event because 8 by 8 gives me 1, and whenever we get 1, that is the probability is 1, so we call it a sure event. That is sure shot it is going to happen. So any card that you take, you're going to have one of the letters from Sunday or Monday. Correct? So that's it. I hope you have enjoyed this session on probability. It was fun learning with all of you, and we'll again meet in the next class. Until then, keep learning with top scholars. Thank you.